And welcome everyone to the final episode where I'll be reviewing 3 laminated chipboard panels from different manufacturers. Before I give specific recommendations on where this material should and shouldn't be used, I want to briefly explain what this material actually is and what you need to understand about it in general. So we have 3 manufacturers, Arbor and Kronospan. Both are Austrian companies, and SwissKrono. As the name suggests, that's Switzerland. Now, an important point, this is fully factory-made product. In other words, it's a ready-made board from the manufacturer. It consists of a practical board core covered on both sides with laminate. That's what makes it a laminated chipboard. It comes in different thicknesses, I'll get back to that later, but the key idea is that it's a finished industrial product. Now let's talk about what manufacturers say this material is intended for. They state that it can be used for cabinet structures, fronts and horizontal surfaces, including work surfaces provided that proper edge bending is applied. And here is a very important note. Kitchen countertops are a completely separate category and are not included in this at all. So yes, with proper edge bending and correct processing, it can be used for certain working surfaces. Now let's talk about how these boards are made and processed in general. Again, the board consists of a core, practical board. Essentially, it's a kind of sandwich made of wood chips and sawdust. The inner layer is made of larger chips, while the outer layers are more densely compressed. This gives the surface more hardness for applying the final laminate layer. The inner core, on the contrary, is intentionally made softer, and this will matter when we talk about fasteners. Next, 2 layers of laminate are applied to the practical board core, and that's the form in which manufacturers supply it to the market. Some manufacturers also produce edge bending, but that's a separate topic. There are many types of edge and adhesives used to apply them. I'll cover that in a dedicated episode. Once this material reaches a furniture manufacturer, it needs to be cut into parts. After that, it's processed depending on the purpose. In some furniture, certain edges are left exposed for joining with other parts. In higher-end furniture, all edges are typically finished. For this, automated edge bending machines are used, at least in modern production. There are also garage methods, but we won't even go there. So the basic workflow is simple: cut the panel and apply edge bending. Why is all this important? Because since these boards are produced by large industrial manufacturers, the results of my tests don't really require repetition. Quality standards are already very high, and laminate quality doesn't vary significantly from batch to batch. The same goes for edge bending, it's also mass-produced. So the only real variable is the final processing, how well it's cut and how well the edges are applied. That's why the conclusions from this test are generally reliable and applicable across the board. Now, speaking globally, there are several standard thicknesses. All 3 manufacturers follow the same range. Thin boards 8 and 10 mm, standard boards 16 and 18 mm, thicker boards 25 mm for specific applications. There are also 38 mm variants, but those are niche or countertop specific, so we'll skip them. The most common thicknesses worldwide are 16 and 18 millimeters. You could say over 99% of furniture is made using this, and most hardware is designed specifically for these thicknesses. For example, one of the most common fasteners, the confirmat screw, also known as a Euro screw, was designed specifically for laminated chipboard. That's why I mentioned the softer core earlier. When the screw goes into a pre-drilled hole, it doesn't split the board. For example, MDF would crack under the same conditions. So, in terms of fastening, 16 and 18 mm boards are compatible with almost all standard hardware. Thinner or thicker boards require different approaches, but we won't go deep into that now. Just understand, thickness directly affects both fastening and production technology. Next, important point, milling. If you want to understand it, let me show you an example. Here is a painted front, I haven't cleaned it yet, it's for the next video. This is a milled part. It has raised and recessed areas. Now, laminated chipboard is a factory finished flat panel. You cannot reshape it. The laminate itself cannot be stretched, formed or reshaped, so it will always remain flat. That's something you need to remember. Now let's talk about decorative options. All manufacturers offer similar categories or finishes. Solid colors, wood textures, a wide range, stone, concrete, marble imitations, and special materials. For example, Arbor offers fabric textures and metal-like finishes. Other manufacturers have similar options, but Arbor is generally considered the industry benchmark. They lead in design innovation and have the most structured and advanced decor palette. That's why others often try to match them. Now let's move on to the test results. For detailed breakdowns, check the previous episodes. So, stain resistance. All boards perform similarly. This is due to high competition and high quality standards. About strength, generally comparable, but with some peculiarities. See the strength test episode for details. Moisture resistance. There are differences in how the core expands, but in practice it doesn't matter much. If both materials fail, there's no real advantage. About fire resistance, also similar across all boards. They performed well and showed no major differences. Now let's talk about real-world applications. I divided furniture into zones. First, safe zones. Wardrobes, shelving, living room furniture, nightstands, dressers, TV units, etc. Here, requirements are minimal. You can use this material without concern. first specific zone: children rooms. Main factors: stains, scratches, impacts. These materials perform well here and are suitable for all parts: structure, fronts and surfaces. Next specific zone: wet areas. Bathrooms, laundry rooms. Focus: stains and moisture resistance. Stains are fine. Moisture depends on exposure. If there's constant water contact, problems may occur, even with good edge bending. Even high quality edge plus poor glue won't save it from prolonged exposure or flooding. Next specific zone: hallway. Main risks: scratches and impacts. Material performs well, suitable for all uses. Now, another important point: all these zones can include functional surfaces. Tops of dressers, desks, consoles, non-kitchen countertops. Again, stains, scratches, impacts. And yes, this material works well here. I can confirm all this from years of real-world experience. Now, kitchen. We must separate carcass, fronts, countertops. Countertops completely separate topic. For carcasses and fronts, all properties matter. Stains, important. Scratches and impacts, important. Moisture, important, but short-term exposure is key. Steam resistance, very important. Examples: kettle steam, dishwasher steam, oven heat. That's why I did the fire heat test. At 100 degrees, these materials behave safely. You don't need to worry about steam or hot water. Now, fire resistance. These materials are not designed for direct heat or open flame. But with the normal use, everything is fine. Now, kitchen countertops and wall panels are absolutely not suitable. Why? Insufficient scratch resistance. Insufficient impact resistance. One hit with a frying pan and it's damaged. Even true moisture resistance is fine when intact. The lack of durability makes it unsuitable. Same with heat. It's not designed for hot cookware. Now let's wrap up. I've explained where this material works and where it doesn't. Overall, it's a very good material. It covers most furniture needs. But you need to use it wisely. For example, hallway, no water. But if there's plumbing there, different requirements apply. And finally, a common question. Can you use it for window sills, slopes, or outdoor furniture? No. These materials are not designed for constant humidity or outdoor conditions. Window areas have constant moisture fluctuations. Outdoor use is even harsher. The only scenario if you are okay replacing it in 6 months, that's it. Thanks for watching, see you in the next video.